Good day and good night to you, wherever you are and whenever you are watching this. This is another GOTO Unscripted interview with me, Kevlin Henney. We are recording this at GOTO Amsterdam 2022, or 2020 as it would have been. And today I am joined by James Lewis. James.
Hello, Kevlin. How are you doing?
I'm all right. So James is, let's get this right, technical director at Thoughtworks, involved in the technical radar and tech advisory board. There's a lot of word tech in there, isn't there?
Yes.
Yeah,
yes.
You know, 3 T's.
Yes.
You know.
Tech at core, we say.
Tech at core, there we go. Now, very much at that core, you're going to be giving a talk here, in fact more T's, on team topologies, there we go, T's, software architecture and complexity.
Yeah.
Okay, what's it all about?
What isn't it about, I think, is probably the real question. So, I mean, I've been fascinated over the course of probably the last 10 years or so by the ideas coming out from complexity science, right? Complex adaptive systems thinking, and particularly a lot of the work that was coming out of the Santa Fe Institute to do with something called generative science. It's this a third type of science. After doing a bunch of research and reading a lot of papers from them, I started to see a lot of similarities with the previous work I was involved with around microservices and software architecture, distributed systems. In terms of the way complexity arises from simplicity. And one of the things I think with when you look at microservices and the original sort of ideas behind microservices was this idea of taking big things. Sam Newman's got the line about, what do you do if you've got a big problem, right? Well, you turn it into lots of small problems and solve them independently, And that was one of the kind of founding ideas, really, if you like, of taking big things, making them a lot smaller, and having them, isolated from one another, so that multiple teams could work on them independently, so you could scale, development effort. And so on, and pushing governance and things down to those teams. But then there's been, as I say, a lot of research from Santa Fe that talks to some sort of underlying, almost like physical properties of, it appears, everything, more or less, like reality in some ways, around how different types of systems scale. And they seem to have similarities with some of those ideas around decentralization, around, as I say, pushing information down to the point or the people who know the most as opposed to them knowing the least. So that's the sort of complexity bit. The software architecture bit is the link with microservices and my journey over the last sort of 10 years understanding what I think is maybe some of the underlying principles and how that relates to complexity science. And then the team topologies bit, I think, is fascinating because there are very few books or pieces of research that that you find, I think, in our industry, which almost immediately become canon, become a sort of immediate reference work. And I think team topologies is one of those pieces of work. It's the reason I love it. I talk about this. I'll talk about this tomorrow. Is it provides us with, in domain-driven design terms, a ubiquitous language to talk about structure, to talk about. And via Conway's law, therefore, structure of software as well, right? So, and of course, I also relate quite strongly to the team topologies folks because, I think a lot of the work, it's almost a meta-study, right? It's almost a big literature survey. In the same way that microservices was a big literature survey, in a sense, right? It was taking a bunch of stuff that we know works and doing them all at once and turning it up to 11, to quote Kent Beck from XP Time.
No, he only turned it up to 10. I don't think he'd watched. I don't think
he'd watched it.
No, I don't think he watched Spinal Tap. Yeah, you see, because when I looked at that, it's just like, no, you turn the dial up to 11.
That shows how much younger I am. Maybe I don't know. Getting the second hand.
Yeah. So there's a lot of interesting things in there. I mean, I think first of all, one of the things you're really kind of pushing towards is that a lot of the complexity, there's the technical complexity, but there's the socio-technical aspect. In other words, software architecture is a socio-technical construct. It's not just a purely, and I think a lot of people approach it as if it is just a technical thing. You can kind of see this in the diagrams that people draw. Often it's kind of one of my standard lines is like, okay, where are the people? It's like you show me all the boxes, and, or you show me data flows and databases and all this kind of stuff, but where are the developers? The only people are normally the customers. It's like, that's fine, but who lives in an architecture like a building? Who lives in it? It's going to be people, and those people in this case are developers, and that shaping factor, and particularly that idea of the Conway's law kind of phases in and out of fashion, and it seems to it kind of picks up a little more empiricism each time round, and that it kind of is properly being acknowledged. And I found one of the interesting things, and certainly looking at the team topology stuff, that I found interesting, because I normally do the dichotomy that people normally had is this, feature teams versus component teams. And it's just like, and whenever I've talked about it, I've said, this is too simple. I want you to understand that there's a whole spectrum here, and that when one person is advocating one over the other, it's much richer and more complex. And team topology seems to speak exactly to that by offering a richer vocabulary that structures. And actually, this is the nature of this problem, therefore follow through to this kind of team structure, and so on. And it's much richer than the kind of the binary view.
Very much so, and I think. Very much so, actually, and I think that's one of its strengths, is acknowledging that not all things are the same. Because I think, as you say, sometimes we can be very binary. We can say, well, either you do this thing and it's a product team, or you're going to be going across in horizontal layers, or as you say, a feature team, which I guess you can have feature teams which just pick up the next feature on the queue, right? What I like about it is it says, no, actually, there are some problems that are fundamentally really hard, and you probably need some specialists. I could argue, I'll give you a couple of examples. There are probably a bunch of mainframes that are sitting in the UK government at the moment with, I wouldn't say 3 people who know how to run them, because that would obviously not be the case, but not huge amounts of people who know how to run these things, right? These are big, complicated, older systems with real deep specialism needed to actually operate these things now. Or if you look at, I don't know, I spent quite a lot of time in front office investment banking, and you don't just dump any developer and ask them to do a quant's job, right? I mean, there's a really specialist set of skills that you need to solve certain problems. And I think that's one of the things that Team Topologies is really great at acknowledging, is actually sometimes you need they call it complicated subsystem team, right? Obviously. And sometimes you need that. But you also need those product teams. You also need teams that are solving the problem of scarce resource. Solving the problem of we know we need more InfoSec people, deep, good, pull it left InfoSec people, but there aren't that many of them. So how do we solve that problem? Get them to act as consultants. So I really like the richness, as you say, of the model and also the vocabulary.
And I think that's interesting, because sometimes it's very easy. Particularly given the kind of the rich nature, diverse nature of software development. You can be in one part of software development and think that that's the whole universe, and then you go and talk to somebody else and actually discover that you have no shared experience.
And that Node isn't that fast.
Or that they just come out with alphabet soup that you've never heard. And I think that in one sense that's always been the case, but it's more obvious now because we are probably more connected. I certainly know that was it was a conversation my wife and I had with our neighbour nearly 30 years ago, and it was this guy, lovely bloke, and it was a case of bumped into her in the pub, and my wife said, isn't that our neighbour? Yeah. So I had a chat with him, and what do you do? Because as neighbours, you don't talk. And I said, I work in kind of real-time systems. It's all this curly bracket stuff and everything. And he works in COBOL, and it's just like. And my wife, who was observing the conversation, said, and at that point, you both took a completely different path in the conversation, because you had absolutely nothing in common. But these days we're probably more aware of it, because these days we are genuinely aware that there is so much going on that no two developers are going to necessarily be able to speak to each other, and that is exacerbated by the variety of architectures.
No, absolutely. I mean, I totally agree. I mean, I think, so back, I think when we first met, we were talking about this earlier, back in sort of 2006, 2007, still very much the pattern language, the pattern community was really, really super strong, right? And I'm not sure if we've lost some of that over the years, or where some of that has gone. But I still think we definitely need to be developing these languages by which we can communicate across these divides. I mean, you talk about the pace of change. I mean, I'm involved, as you sort of said, in the Thoughtworks Tech Radar. So every 6 months we get together and we all bring a bunch of new ideas or new things that have been recommended to us to include. And there's 300 new things every 6 months to talk about. 300, and this is like not all of them are JavaScript libraries either, right?
Yeah.
Not all of them are
JavaScript libraries, only 250 of them.
Yes. Yeah. I mean, half of it obviously is state management in React, but not all of it is JavaScript. And it is astonishing. I mean, it sort of reminds me a little bit of the fragmentation in the scientific community, right? Where it's impossible now to know everything. Yeah. And now we're starting to see the advent of machine learning models being used to try and solve the problem of not being able to know everything anymore.
Yeah. And I think that becomes interesting because it's very easy to be in one corner. So let's take the kind of full stack developer notion. There's some people there just like, full stack, and their stack is quite small, but it basically means that they are typically a cross-functional developer and they're capable of working at front end, back end. But it immediately tells us we have an architecture with a front end and a back end. That's actually a huge narrowing at that point. And they're potentially a generalist at that point. But then that also leads to people wandering out into the industry saying, everybody needs to be a cross-functional developer. It's just like, actually, it turns out that there are certain specializations. I deal with, for example, in the past, dealt with games companies and console games companies. It's really interesting, the specializations that you have. It's not all just talking to the metal, is that you have people who are specialized in music. You can't just drop somebody who is non-musical into that role. Or somebody, I'm responsible for the physics of this. Again, that's not just learning a new framework. That's a genuinely different thing.
That actually really reminds me, because over the course of, during the first lockdown, I ended up exploring a product idea that I've had on my mind for quite a while, actually related to some of the things I'll be talking about tomorrow. But one of the aspects of it was it's kind of, if you squint a bit, it's kind of game-like, right? It's a simulation kind of engine, kind of game-like. And of course, being a fool, being an idiot, I thought, well, what do these game folk know about software development, right? So I'll just write a bit of C# and suddenly I had that. Is it the 10th law? Any sufficiently complicated object-oriented system has got a half bug-ridden implementation.
That's right. Yeah.
Well, I ended up with like the same thing, but for a game engine, right? In my code, I had a game loop and I had like rendering loops and I had all the things that you go to GOTO, which is a great open source game engine. Look, it's all there for you, right?
Yeah.
But also, I think the interesting thing with gaming, with game studios in particular, is the separation that they have between, and I think this is something we need to learn in the rest of the industry, actually, and we're starting to go on the path with things like the platform product teams, actually, again, team topology, right? Teams that are building tools for other teams.
Yes.
And that's what they're really, really good at. Most people in the game studio aren't. There's a lot of people building tooling to support the others who are using the tooling.
I think my first interaction with the games industry was about 2000, 2001, and I'm not going to claim to have any expertise in this, but it's kind of like I visit the games industry like kind of every couple of years, and then it's just like, it's changed, and there's this clearer commodification, this platform separation. There's a lot more that gets outsourced these days, but there's also a lot more that moves what they're doing with the shape of teams and how the responsibilities distribute and what gets commodified, and that whole idea of the platform. And again, in team topologies, you see that kind of, there's platforms, then there's the recognition of complicated subsystems, then you have the stream aligned, which gets closest to feature teams, and then you've got kind of enabling, which is just every now and then you just need a little bit of a push somewhere to make something happen and bring in some expertise. And that's a much more dynamic and to pick up on what we said before, a much richer way of viewing it. And that idea that we have these different degrees. There's cross-functional developers, there's cross-functional teams where we may have everything there, and then you may have across the teams cross-functionality exists, but the whole brings it together, and that I think is a more nuanced way of looking at it. I think everybody would like a simple answer, and I think sometimes it's very easy to fall into that trap, but every now and then you stumble across a domain, and it's just like, actually, I can't casually be a tourist in this. It's like I've got a couple of clients who do medical imaging. It's just like, you can get a whole master's degree in medical imaging and only feel that you're at the beginning of that discipline. It's just that's not a one I can just be a cross-functional developer in. And
there's an interesting example from that actually, and it's something I never thought it would be an interesting example. I never thought it would be that interesting actually, because you've got these are really deep technical algorithmic problems, but there's also these really complicated domain problems or complex domain problems. Trains. You ever worked with the trains domain? Unbelievably complicated domain. Like, things turn into other things halfway through. We have a train, and it's fine, it's a train, it's got an ID. At the end, it's a different train. Well, how can it's the same physical, no, different train. So no, it's the same train. It's just really complicated and really fun to be in, Solving some of those problems is super, super fun.
And that's a really interesting one, because there's a discipline that has grown up, and it's clearly massively effective given the train infrastructure in every single country. But there is a rich domain that's already got a vocabulary, it's already got a way of working, and it also challenges our ideas of this train. As you said, this train is this train. It's like, the concept of identity is, we wander into philosophy here. The concept of identity is actually a lot harder than you thought. And where trains split, or a single physical unit can actually change its identity en route. But what if one train becomes two trains and one part takes the original identity? There's all of these questions that have traditional database people screaming. It's just like, no. Can you simplify the domain? No, you don't get to simplify the domain. The domain is a given. You get to simplify how you implement it, but that's a given, and that really does challenge people. But then also, it's another case which I think is interesting, and it's perhaps a little different to some of the disciplines that we normally end up with, is that it directly talks about something in the physical world that you can't redesign. I can redesign a shopping basket in an app. If I'm doing an online shopping thing, then actually I get to shape my world. I can change it as much as I want. And there might be common business practices, but I really only have to respect the rules of accounting. We don't get an option on that one. You can try being creative, but somebody will find you. But when you're starting to deal with rolling stock that actually is moving things across physical structures, and it's just like, my software touches the world and the world touches the software, this is a bigger problem. Obviously one of the great things about being a consultant is you get to see a lot of different stuff, right? And this wasn't something I worked on directly, but it's always known internally as the cow project. To talk about this physical world. And it was an IoT project and machine learning project to understand how to optimize milk production for farmers on farms. Again, you can't get much more physical than that. And the brilliant thing about that project is we had BAs, we had some of our analysts in wellies on farms, actually, with the farmers, because it turns out they wear big gloves. There's another example from some friends of ours, probably joint friends at Equinor, the Norwegian state oil company, and they've got this brilliant case study where they talk about building digital twins, essentially. So AR apps for iPads, I think is for iPad, or maybe it's a hardened tablet of some sort, to diagnose problems on rigs. So when they've got a problem, you can point this thing in and it tells you flow rate and all this kind of stuff, because they know the assets, what the asset is and things. But of course, when the developers sitting in their nice warm office in Tromsø or wherever they were kind of developing this, they came up with a thing that when the people who were working on the rigs will have to go in and actually use it, they're like, well, look, there's a force 8 gale going on. I'm flying around like this. I've got these thick gloves. How am I supposed to be? So they actually, brilliantly put the developers through offshore training and sent them and gave them their first version of the app and said, right, you make it work. And of course they couldn't. I think that's intersection with the real world, solving real world problems. But it is, because that's the thing, is that I think that it's very easy sometimes in the software space to reduce everything to a software problem and then not recognize it. Goes back to what you're talking about in terms of complexity. A lot of complexity arises not just from within a domain, but how one domain of description where interacts in a very weird way with another. And I'm going to borrow from Michael Jackson, No, not that one, the other one. Michael Jackson, the requirements guy, and his stuff on problem frames and requirements. And he talks about these domains of description as like the way we describe an information system is fundamentally different to the kind of things about a physical system. And then how do they interact? And there's a different story there. And that's actually part of that becomes the part of what becomes our software architecture, part of where the complexity arises. Each domain on its own might be simple to describe, but bring the two together and suddenly there's all these possibilities. And so this is really quite literally out in the field, for the cow example, quite out in the field trying to discover this stuff. But that idea of, I have a friend who similarly, software, yes. Oil platforms. It was just like that was one of the things he had to have. Was offshore training, and it's just. It takes it, as you say, away from that kind of keyboard view of the world. And I think sometimes we get this with, it's a tendency of many mobile developers not to concern themselves with offline development. It's just like, so, you're assuming you have good bandwidth everywhere. How does this behave when you take that away?
That's another great example from that, which was, it was an aid agency actually, and they came and asked for some advice around rebuilding one of their apps. And it was a pretty simple app, really. It was to do with registration of people's details. Essentially, they were operating in Africa and with rescued child soldiers. That was their kind of domain. And one of the sets of requirements was, okay, how do we literally burn this? Because if the camp gets overrun that they're sitting in, what are the options that we have? Do I just carry a hammer with me so I can smash the hard drive? Because of course, if encryption is a thing, but then the offline thing. There's not much internet coverage, if you're sitting in a refugee camp in Africa, in lots of Africa, and also syncing. It was a distributed system problem because they had a copy of a database in the sort of head office somewhere, and they had to sync the local copy with it, with no access. So they'd literally put like a USB key on a guy with a donkey over a mountain to go. It's like very, 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 very high latency, but quite large bandwidth.
Yeah, decent bandwidth. But exactly that becomes part of your problem domain. In other words, sometimes I think it's easy in development to just sort of say, well, that's kind of like that's an implementation detail, or there's a kind of almost a mental boundary that we draw around something in order to simplify it. So back to the kind of
and this is just on that point, and it comes back to thinking about the domain-driven design, ubiquitous language, and diagrams and the type of things people draw. And I think the big shift we've seen, but I think it's not quite there yet, is the switch from drawing the diagrams of the technology to drawing diagrams that represent the domain you're working in. So the business capabilities that you're trying to implement. I think that's been probably in the last 10 years, 12 years, the biggest switch I've seen. And I think that's actually a super, super important thing, because it's the focus on the technology, I think, that gets us into too many of these of the rabbit holes. The technology is a means to an end, unless you're an Intel chip designer, in which case, obviously, the domain is the technology, but it's the means to an end.
But I think also that reflects our kind of, we have a strong solution centrism in software, and people are drawn to the technology, but it's that idea, and it's interesting because when we start looking, you mentioned diagramming, I think that's interesting because I've had this kind of relationship with diagramming that goes back, many decades. And it's been interesting to see how it's evolved, how it's been taken up or pushed down at various times. And so we have something like historically UML was very much anchored in the idea of I'm trying to describe the technology. And much as people would say, oh yeah, you can also describe the domain, that was an also ran. It was very much, in fact, a colleague a number of years ago kind of betrayed the reality of it when he described everything. It's like, he was talking from a C++ perspective. He said, it's like visual header files. And it's just like, so all of that chat about I'm trying to do the domain model here, completely lost on most people, because it does come from that. And certainly my work with some BAs years ago on a kind of more agile adoption, I focused initially on the developers and then I focused on the BAs, and actually I got much more traction with them. But what I discovered is that that's not how they're thinking about the problem. Not even close. I mean, not even like translatable close. It was just like, okay, so we ended up using, interestingly enough, we did end up doing a lot of diagramming, but the diagrams that developers would by default try and offer as common language didn't have anywhere to land. That's not how so we chose a different shape. And we chose some standard notation, we chose some non-standard stuff. But it was a case of like, that's not how the BAs are thinking about it. We're developers imposing a solution on a space. UML is another one of those, and people have loosened up a bit in the notation department.
I think, and I think a good example of something that really works is the visual language in Gregor and Bobby's enterprise integration patterns.
Yeah.
I mean, I think that is a fantastic example of a visual language that exactly suits the domain that they were trying to represent. I mean, you'd be happy to have an omnigraphal template with your diagrams in, wouldn't you? That'd be pretty cool. My favourite thing, but I'm sorry, I'm full of old stories, so I apologise, but
that's exactly what we want.
My favourite class diagram story or UML story was from a former client, so many years ago now, probably back in 2007 or so, and they had a classic ivory tower architect who insisted on class diagrams. Where the class diagram? But we had like 40 people writing code. It was continuous integration before continuous delivery was named, but doing continuous delivery. I think Dave was actually on that. Dave Farley was on that project, I think. And so we had a lot of people writing code, committing multiple times a day. Write a test, make the test pass, refactor, commit. That's the on the main line. But it's like, where's the class diagram? We're trying to explain. It's like, look, the code. It's the class diagram is the code. You can't tease these things apart. The running software is so. In order to satisfy this architect, one of our devs, basically every commit would dump out a representation of the entire code base in dot format, and then would send a class diagram by GraphViz to the nearest printer, and would print out.
That's continuous delivery.
50 pages of class. It's the current class diagram. It's the current, and you've got 40 people committing once every 20 minutes or so.
Yeah, I think you see that's the thing is that
it stopped very quickly instead.
There is this absolutely fascinating thing about. I think, and this is true of all tools, all decisions, that when there is this idea that it's just like, here is a good idea, but often the bit that's missing is why something is a good idea. So then what you end up with is people start advocating diagrams, but not understanding what problem they're solving. And that leads to some very interesting and bizarre adoptions. And I have one at one company where somebody, here's basically the domain model, and I'm looking at it. It's got 10 classes on it, which is not a whole load. Then I'm looking at it and going like, most of these are infrastructural. They're controller type things, and then I kind of look a bit closer, and it's just like, you do know there's only 2 actual domain classes on this, and the developer kind of looked at me and said, oh, I wondered if you'd noticed. He said, because I initially drew the class diagram and there were only 2 classes on it, and it's just like, it looked a bit empty, so I added others. And I said, well, there's a really simple reason, because your domain is actually, from a data point of view, it's not very interesting. It doesn't have a rich data model. There's plenty of data. Oh my goodness, there's loads of data, but the relationships between the data are actually not very exciting. But the workflow, that's where your domain is. In other words, it's kind of like your projection is wrong because you're a developer. You're thinking, classes, visual header files. That's the thing. As opposed to, what's the shape of the problem here? Why am I doing this? Are you drawing a diagram to keep another person happy because they said diagram, or are you drawing a diagram to show something that is otherwise not easy to show? And the workflow, that was the invisible thing. It's just like, the workflow is, you can't point to it, and yet it's everything this organization runs around. If you draw the workflow, that's where your domain is. Your data thing's not very interesting. Sure, put it in the database, but actually, you end up with that.
And I think that's, event storming. I don't know if you've done much event storming recently, but I think we've entirely wholesale adopted that in Thoughtworks. It's been, it's been a bit of a revelation, actually, to be able to have it all. Okay, it's a one-size-fits-all, in some ways, kind of a bit of a hammer to solve most problems, but it does surface these the variety of interesting things about domains, not just the static, not just the data perspective, the infrastructure perspective, but the workflow. I mean, it reminds me a bit of Martin Fowler talks about semantic diffusion.
Yes.
The why gets lost, or the why, the meaning of the why changes in some senses. He talks about that with Agile over the years, and how that's, you end up with the cargo culting, and you end up with the process is the means to the end rather than the rather than an approach that helps you get to the end. And I think microservices is the same. That's also gone through this, this period of cement. Why would you break up something into smaller bits? What are the reasons you would do that? And that's I think has been lost as well. I'm not sure what Fred's thoughts are on this these days, Fred George, but I haven't spoken to him in a while, but there's still all the questions around. With microservices first, we're going to, and still most of the time you end up with a distributed monolith built around nouns. And it's people don't stop to ask why.
By coincidence, I was talking to Fred George yesterday, and this question came up actually. So and he says actually the term, and exactly it's semantic diffusion. In other words, a term arrives, it has a precise meaning. And I was talking to Fred about this actually outside of the outside of our unscripted discussion, because I said, well, it used to be, I said you were the first person I heard really talking about this stuff, and you actually had a concept about microservices that was very much bound to the word micro. In other words, there was a notion of scale that distinguished it, and that sizing aspect was actually a fundamental import. It's the idea that you have only a couple of people on it. It is a scale-related thing. It's independence, but it's also a quality that I refer to as the high discardability. In other words, you could throw the code away. The discardability of code. What happens if I throw this away? Now, clearly for a monolith, that's a question that would, if you were to say that at a table, a meeting, and it's just like people go like, no, that's not the thing we're going to do. No, it's a thought experiment. I want you to engage in this. It's like, no, we can't even think about it. Versus, oh, this is so small. Of course, yes. We can easily. We see the shape. We see the shape of its hole, and yes, I could re-implement that using a different technology and just pop that right in there. Another developer could come, and that was the micro element. In other words, he had a very strong size idea, but he also said, actually most of what people is doing is just service-based architecture, but the term itself has generalized to include everything that was not micro. It is services, and there's only out there a few things that are micro.
You could argue that we've reclaimed service-oriented architecture away from the big vendors, right? In some ways, although they're doing their best and have been doing their best to take it back. But I think the discardability, the disposable aspect of these things, I think that's super interesting. And I think there were some tropes that pop up, some almost like the memes in some sense, right? In the kind of like mimetic virus kind of sense of the word. And I think so. I did a talk quite years ago now, called "Building Software That's Never Done." Right? And it was about what changes in the world if you're building disposable software. What are the practices that are still relevant? What are the tools that we can still bring, from our toolbox to use when we're in this world? Because talk about the monolith, we're not throw that away, But still, for most product managers, most folks who have the money, saying, oh, we're just going to have a team that's going to build this forever, right? And when we learn more, we're going to throw it away and start again. We'll build another thing. And that is not how. It's not even just how people's minds work. Often, it's how the financial structures of organizations aren't set up to support that way of working, right? Because you're building a thing which then goes on your books for 10 years and then it comes off your books, right? That's, you build a thing, it goes on your books for 10 years. That's how you finance most of this stuff in most organizations. And so this idea that you would have these, and we talked about in the thing that the paper that Martin Fallon and I wrote, we talked about long-lived product teams. This idea that you're never done, that you're maybe the platform API team at Netflix who rebuild in 3 different languages over the course of how many years. But similarly with, I think similarly with things like team structures, right? There's a again, I've been enjoying reading the work on swarming that's been written about quite a lot. Things aren't fixed. We should recognise, we need to recognise that things aren't fixed. And even if we think they're fixed, and again, this is back to complexity science, even if we think they're fixed, they're not. People go on holiday, And if I go on holiday for a month and come back, the software will be different than if I'd been there for the month, right? I mean, that's an unavoidable outcome of me not being there. And so this idea that things are fixed and should be fixed, I think is one of these things that has just become an accepted an accepted part of our reality when we're writing software. And I don't think it's, I think that's one of the things we are learning, I hope, is the impermanence of all these structures and the fact that we need to optimize for change and not for permanence, if you like.
I think that change is a scary thing, and I think that's actually, I think it is our sort of inability to visualize and conceptualize that change, that it's as developers we often approach things, we want to simplify things, but actually I'm not even going to just attribute this to developers. I think as humans, the world is a complex place, so therefore we look for simplifications. We look for, well, let's assume that doesn't change. In other words, we go around, what if I have a set of development principles that everyone follows, and that just simplifies that? In other words, we're kind of pushing things into the kind of like the Ron Kevlin debate. We're oversimplifing.
Yes.
It's just I would like this to be simple. The fact that it isn't doesn't change my... And it turns out it can't hear my preference. So what we end up is that it bites back. It's just like, I have this simple view. I'm going to make development is going to be these principles, and we're going to follow these rules, and here's this. And I'm going to push this into this box. It turns out that it kind of springs out because it's just like, no, that's not the nature of this thing. And that impermanence, I think, exactly as you say, even down at the level of an individual going on holiday, that idea is that sometimes people like this fixed idea of teams. Well, if we can keep that fixed, then that allows us to think, it's just, but it's dynamic. And again, Team Topologies expressly sort of says, this is changeable through the life cycle of a product. These will realign. You may discover new problems that may move you into a different space. You suddenly realize, the way we've made up the teams at the moment is not meeting the class of changes that we are now experiencing. Actually, we're set up for a different era. We're quite literally programming in the past. We're programming according to a model. We're built and we've organized our teams according to yesterday's model, not today's.
But as you say, I think it's human nature, right? And I think a lot of it is people don't know what they don't know. I know to coin the old, the old phrase, but again, I think that's why I've been very lucky as a consultant. Is I've seen lots of different stuff. Most people don't get to see lots of different stuff. Most people get to see, it's the old thing about do you have 10 years of experience, or do you have 10 lots of 1 year repeated over and over again, right? That's the thing. And often when when I work with an organisation, half the time, my job is like I talk about elephant spotting. It's like because I can walk in and see the footprints, right, in the butter or whatever in the fridge, right? Because but then if you've been working there for a while, you don't get to, you don't start to question, why do we do things like this? Why are these rules that we've got in place for teams, for how we build software, for the principles that we use? Why? Where do they come from? And this is another thing about the talk, exploring the talk tomorrow, is what happens as companies get older. Actually, right? And there's some really interesting research around. I don't want to, spoiler alert, but there's some interesting research that seems to point to the fact that as companies age, that similar things starts to happen that happens to mammals when they age. Right, so they exhibit signs of aging, and they do that by getting slower and by getting kind of increasing depth of hierarchies, and these sort of things tend to happen over time. And they start to switch, in particular, from a focus on the thing that made them successful, which is product development of whatever type that they were involved in, to almost keeping the organisation running. And so rather than it's rather than invest in growth or new product development or research and development, they to maybe to overuse the metaphor, they have to spend so much of their budget, of their energy on keeping themselves alive, on repairing damage, if you like, to the organisational structure. That inevitably they slow down, they age, and often die. I mean, there's an amazing fact, which is from the book Scale by Geoffrey West, which is there's a half-life of a company on the half-life of a company on the exchanges is about 10 years. 50% churn every 10 years. And
it's dropped, as I quoted a figure in a talk last year or the year before, on how much this this cycle is now moving faster. And what is interesting is that when you look at that, and there's a really nice piece on kind of the longevity, or a time-sensitive version of Conway's Law by Rob Smallshire, where he basically looks at, the idea is that it's not just the forces of the people in the organisation as it currently exists, but as they were in the past, because they live on through their code, so to speak, and that exerts a force on the day-to-day, and so Rob really explores this, but he also uses a half-life model where he talks about the half-life of various things, and it's just like half-life of developers is a couple of years on a piece of code. And then we end up with the half-life of actual bits of code is really long, and the code is now outliving the companies. And that's the thing. We're finding there's this interesting kind of shift in the rates, and it goes against our mental assumptions. There is this idea if we were to, we like things to be nested. It's an instinct that is a massively simplifying instinct. We see it in our code. Blocks nested inside other blocks. People draw it up in nice container diagrams. This is inside this is inside this. It's great, and we like the idea that here we have a product and it contains code, and this product is in this company, and it's just like, that's not how it works. When you look at the lifetimes of these things and their influences, it escapes the box, quite literally escapes those boxes, and it's a radical oversimplification. It's far more complex.
Yeah. I mean, I am quite interested in the idea of self-similarity, as in at different levels of abstraction. Because what was one of the things I would talk about in microservices is this self-similarity. It is to a certain extent, especially around things like the single responsibility principle, so the single reason to change. I think there is an interesting argument to be made there that is a unifying principle all the way up and down. I think. In terms of software architecture, in terms of writing code, I always talk about this idea of chunking up. Dan, actually, I wholeheartedly, that's the wrong word, I just stole it from Dan North, Daniel Tillhurst North. You talk about chunking up levels of abstraction, and the domain has to make sense at the level of abstraction you're thinking about it in. And this idea that when you chunk up from different levels of nesting, to other levels of nesting within an organisation, that there should be, I think, some form of self-similarity. But this is a really interesting idea that actually that you can't have that potentially.
Yeah,
right?
it's a simplification, and the way that I guess I've always pitched it is like software is fractal. There's a kind of a scale for everybody, right. And there's this idea of, and that's a distinction with many things in the physical world, in the sense that we make larger bits of software out of smaller pieces of software, out of smaller pieces, and it's turtles all the way down, basically. Whereas actually, if I make a building,
until
then
you
actually,
hit the elephants.
There's elephants beneath. So you have that kind of idea that there is this self-similarity, which leads to these recursive descriptions. It also leads to challenges to the way we think about our mental models, because we like to have, we are anchored to the physical world, and we kind of think of things as big and small and all the rest of it, and then I'm utterly surprised that software doesn't respect that, and that, hence why.
So you mentioned fractals.
Yeah.
I mean, I don't know if you know, there's some really fascinating research that talks to the fractal dimension of cities.
Yes.
Which is amazing, and you can measure the health of a city by measuring the crinkliness of its boundary. And I wonder whether you can do the same. I've not tried it, but I wonder how you would come up with a mechanism for measuring the fractal dimension of software, essentially.
I think that's an interesting question, because I think that it is one that, given that software exists in a very abstract space, this idea of fractional dimensions and kind of that crinkliness is a valid question, and it probably tells us something. It's, if you like, it's the texture of a system, and what does that feel like? And it's probably going to tell us something about the lived experience. What's it like to be a developer in this system? Is it a pleasant experience? Is it
getting better or worse? Because this is the thing with
it changes over time.
Exactly. And you can look at, you can derive a certain set of other properties from the fractal dimension changing. So you can say, if the fractal dimension of a city decreases, then if it becomes less crinkly, then the city is getting sicker, if you like. Things like number of the wage growth will start to slow, and unemployment starts to go up, and things like that start to happen. But you can sort of predict that from the it's predictive of the fractal dimension is predictive of those things, which is something super interesting. So I wonder whether, as you say,
potentially, well, given that Adam Thornhill is actually at this
he's here,
conference,
isn't he?
And so this is very much his kind of space. But I think that's an interesting thing, because again it goes back to this idea of grasping something that is inherently complex and giving ourselves a view. How can I, as a human, view and understand something as abstract as a software system with the people working in it? Because it's not a kickable solid thing like a chair. How do I understand it? And we're always trying to find the right point of view. Sometimes our perspectives or models work for one era, but they hold us back for the next change.
Exactly. Yeah. And coming back to this thing about you're saying about Rob's work. If you look over time, what happens? Classic example: regression tests. We have to do regression tests because on that day 5 years ago we had a thing happen.
Yeah.
So now we have to do regression. Well, I've only got this tiny little. It's just an image I'm uploading. No, you have to do 8 weeks of regression tests, right? Because that's what we do now. There is that sort of. What was suitable for yesterday isn't suitable for today.
It goes back to your organisational thing about the fact that organisations move from, I guess let me phrase it a different way, they move from value creation, the innovation, they move from value creation to loss aversion to then how do we keep the thing alive? And sometimes I kind of look at that and I wonder if, we're kind of on a pursuit for scaling at the moment, it seems, both in kind of, why are you doing microservices? Because we're scaling, because it's scalable. It's like, well, are you scaling? No, we're not, but they are scalable. It's like, well, maybe this isn't the solution to your problem. But also we see this again with methodologies. There's a lot of stuff on, scalable agile, whether it's safe or less or whatever. And it's just like, well, the one I guess I always point out is my son used to do CrossFit. And it's just like, they use the word scaling in CrossFit, and it turns out it has exactly the opposite meaning. When you scale an exexercise, you scale down. There's an extra word there, up or down is the question. So when people say we need to scale, they're probably right, but they're probably wrong about the direction. There's an implicit thing there. It's just like, maybe you need to scale down, because maybe your problem is not actually the one you thought it was, and you're making things more complex. And you've ended up dealing with that kind of, you're now feeding the machine. Why does this need to be scaled? Because we have 100 developers. Yeah, but it's a 20 developer problem.
So it reminds you, I'm sure you know the author Charles Stross.
Yes.
I mean, he's one of my favorite authors, brilliant individual. I wonder why we don't have him at more of these conferences, actually. But anyway, maybe we should suggest.
There we go.
That.
This is now on record.
This is now on record. We should get Charlie Stross to come to GOTO to do a keynote. But he's got this lovely thought that the general artificial intelligence is already here. It's just we work in them, running their algorithms very slowly. And I think that's a lovely idea, right? Because in some senses, this is what we're kind of talking about, is at some point, these companies that we're in, they do take on, then they are greater than the complex adaptive systems, greater than the sum of the parts, right? And like, there's another great line from the Santa Fe Institute. I think it was the first second interplanetary festival at SFI, which one day I'll go to. That would be like a bucket list thing to tick. And there's a great quote, which is, if an alien observed the Earth from orbit, they could be forgiven thinking that cities were the predominant form of life. And that humans were the equivalent of their gut biomes.
I think this is, that's a recurring thing, because I know I said that actually, funnily enough, to some friends after my degree. It's just like, if you look from orbit, I said actually, cities and cars are being, and that we are basically the service role, that idea. And again, as you say, this AGI kind of view. I think I first read about that idea of like the organisation and companies are actually examples of AGI from Ted Chiang, the science fiction author Ted Chiang. And it was just like, it seems to be, when we take a step back, and again, it's that idea you're looking at, it's just like, well, let's just change the scale a bit and see if we see anything else at a different scale. Oh, maybe companies fulfil this role. And it's just, and I think that again kind of brings us full circle to why software architecture looks the way it does.
Yes, I think so.
And it explains there's an inherent complexity that arises just from this set of moving parts.
I don't know, maybe this is getting a bit too out there, but we come across the physics perspective on the origin of life. Which one is so this is the one which is basically
sorry. Is this the David Deutsch stuff? Is this the constructor theory, or
this is not constructor theory. This is basically the most efficient way to increase entropy is to create life. So it's a spontaneously created mechanism that more effectively is able to create entropy, essentially, or increase the entropy of a system. So there's this, it's kind of like an interesting kind of like philosophical idea that actually. The only reason we're here is because we're able to burn effectively or calorific content, as is
Yeah.
we're burning calories, we're essentially increasing.
Absolutely, yeah. And actually, so ultimately, there's an interesting thought there, and I guess it's a good place to close in terms of reflection. There's an interesting thought there. Maybe cryptocurrencies and the amount of maybe that's some kind of epitome of physics. In other words, yeah, that's a generally very good way to turn everything into waste heat.
My most retweeted tweet ever, right, was from years and years ago, and it was a kind of a play on a Charlie Stross kind of trope again, which was so one of his books, Accelerando, which is the story of a family going through the singularity and the technological singularity, and in that they start converting the different solar planets in the solar system into computronium, he calls it, in order to run like VMs, right? To run virtual people. And I wrote somewhere when Bitcoin first started. I tweeted, well, not first started, but I tweeted something about we're not going to be satisfied until half the moon is basically turned into Bitcoin mines, right? And there is a bit of that going on.
Yeah, I think you might have underestimated it. Yeah, scary forecasting, and there we go, full circle back to the tech radar. That's a forecast that may well come true. Right. Okay. So there is a lot there to unpack. I hope you've enjoyed this. I certainly have. Thank you very much, James.
I've had a blast. Thanks, Kevin.
And please check out James's talk when it goes online as well. Thank you.